Okay, this particular set of problems is primarily dealing with binomial and also has a geometric. So an airline claims that there's a 10% probability that a coach class ticket holder who flies frequently will be upgraded to first class on any flight. The outcome is independent from flight to flight. Sam is a frequent flyer who always purchases coach class tickets. What's the probability that Sam's first upgrade will occur after the third flight? So first off, let's talk about this. We have a fixed probability. They're independent. This sounds like a Bernoulli. When I get to here, it talks about first. That means it might not ever happen. It might happen on the third. It might happen on the fourth. It might happen on the fifth. It might never happen. So if I was making a number line, 1, 2, 3, 4, 5, ... I'm interested in all these values that are 4 or larger. And because this is a first, this is a geometric. Because I have multiple values circled, it's a CDF. And because I don't have one circled, this is at least. So this is essentially a 1 minus on the geometric, and this is what this will look like. I'm showing my work. And by the way, a geometric is basically a fail followed by the success. Well, in this case, the probability of success is 0.1. That means the probability of fail is 0.9. Whichever trial this on, my numerators have to match. So the probability of it happening on the first, oh, this is 0.9, and this is, if that's the first, then that's to the 0. But in this case, we need it to happen after the third. So 0, 1, 2, 3, 4, 5, well, there's no 0. We need it to happen after the third, so all the way to infinity. So I need to subtract out the third, which means 0.9 and 0.1, and those two all have to sum up to 3. And 2 plus 1 sum to 3. Please remember, this particular one, the success will always be to the first power. I don't care which time it happens, the success will always be to the first power. And the number of terms, these two, the exponents have to sum up to the number of terms. So on the second term, it would be 0.9 to the first, 0.1 to the second. On the third is 0.9 to the second, 0.1 to the first. On the fourth, it's 0.9 cubed, 0.1 to the first. So it's always to the first power for the success, and the failure is what continues to grow. So how do I do this on a calculator? Glad you asked. So 1 minus second vars, geometric, CDF, P is 0.1, the X value, that's the highest thing we're subtracting out 3, is 0.729. So there's a 72.9% chance that Sam's flight was not upgraded during the first 3. That said, there's another way to think about this problem. And it's a little bit different, and I hesitated to show it, and I was like, no, I'm going to show it. In this case, we're looking for a fail, a fail, a fail. In other words, I didn't get upgraded on the first, and I didn't get upgraded in the second, and I didn't get upgraded on the third. And that's 0.9, 0.9, and 0.9. And that also will get me to where I need to go. Okay. So what's the probability that Sam will be upgraded exactly 2 times in his next 20 flights? Well, here we have a specific number of trials. Yay, that means it's a binomial because there's a specific number of trials. And if I'm making a number line, we could have 0, 1, 2, 3, 4, all the way up to 20, but we want a singular value. Because it's a singular value, this makes it a binomial PDF. So 20 choose 2, 0.1 squared, 0.9, because this is the number of successes. And 20 minus 2 is 18. All right. And so to do that in a calculator, second vars, binomial PDF, 20.1, X value is 2, because that's the number of successes. So there's a 28% chance it'll happen twice. Turns out Sam's going to fly 104 times next year. Would you be surprised if Sam receives more than 20 upgrades? So we have 0, 1, 2, 3, ... 19, 20, 21, 22, ... all the way to 104. Now, it wants a probability that X is greater than 20. So 20 is not enough. We need 21 to 104. This is also an at least problem. So I can show this a couple ways. 1 minus 104, choose 0, to 104, choose 20. Or I could have gone about it doing the 104, choose 21, 0.1 to the 21st power, 0.9 to the 83rd, plus ... plus 104, choose 104, 0.1 to the 104, 0.9 to the 0. And what that says is, hey, every single one of my flights got upgraded. All right. So once again, we're running through the calculator, because some people write it down right and then they don't do the calculator right. So 1 minus second vars, binomial CDF, because we have multiple values, and anytime you don't have that 0 circled on a binomial, it's use a CDF. Trials is 104. Probability of being upgraded is 10%. And our X value, we're subtracting out what we don't want. We want 21, but we don't want 20. And we end up getting 0.0013. So would you be surprised? I have to answer the question. I did the math, but I also have to answer. And it's like, yeah, I'll be surprised. It's unlikely that it's going to happen. That's a very, very small percentage.